Hi there, welcome to our first video for the DCC unit. This is called DCC1, Batteries, Wires, and Bulbs. And I have a battery here in my hands. You can see it looks a little bit like this picture. It's got the little nub on the top, and if you look really carefully, we even see a plus sign right here on that nub. So notice this says, we can simplify a battery with an idea of high and low electric pressure. One side of the battery stays at high pressure while the other side stays at low pressure. We haven't talked much about what this idea of electric pressure really means, but we're saying let's try to simplify how a battery works with a rather intuitive or kind of useful idea of high and low pressure. So we're saying, imagine that this side of the battery with the nub is staying at a high pressure and the other side of the battery is staying at a low pressure. This is a good time to mention that if you don't have one of these sheets in front of you, it may not be a white sheet, but if you don't have a copy of DCC1 of some color, regardless of what the paper is, if you don't have a copy of these notes, and if you don't have a pencil in your hand and you're writing down these notes, you should stop watching the video right now and make sure that you get a copy of those notes so that you can be writing along with me as I write. If you watch the video, that can be kind of helpful, but if you watch the video and take notes while you're watching, that can be very, very helpful in the long run. So we're going to go on. This says, if we can connect high pressure to low pressure with a wire, a current of electrons will flow. If we place objects in the way of that current, we can get electrons to light bulbs, run motors, or even charge phones. Before we go on to talk about this in more detail, I want to point out this symbol right here, which is reminding you that there is more to say about this topic here. If you check out DCC2, which is about electric pressure, or you check out DCC3, which is about electric current, you're going to have notes in the future that connect to this idea. So as we explain this, as we learn more about what electric pressure and current really mean, these symbols are going to come in handy as you work with your notes more and more and get more and more accurate and careful notes. So the idea is we can get this battery to do some magical things, like light a bulb or run a motor or charge your cell phone or run your TV or even run an electric car. This idea is huge if we can harness the power of moving electrons. And notice I'm doing that right here. I have a battery which is in a battery holder. There's nothing all that special about the battery holder other than, I'll take the battery out for a second. It helps us make connections easily. So notice this little spring is connected electrically to this red wire, and this red wire is connected through this wire here. So if I put this battery in here, it's like the red wire was touching this side and the other red wire was touching this side. These red wires are not connected to each other. They're connected to the two sides of this bulb holder, which has a bulb screwed into it. And if we look really, really closely at this bulb, I want to point out something special about it. You can see there are two kind of sticks that are sticking up. These are like wires that are built inside the bulb, and the part of the bulb that's actually lighting up is between those two sticks. I don't know if you can see that. Let me put my hand, there we go. So between those two sticks we have what is called the filament of the bulb, which is a different kind of wire made of a different material that's connecting those two sticks. Let's talk more about that. This says a bulb lights only if current flows through the filament. The filament is, again, you should be writing along with me, is the little wire that connects these two sticks. So I'm going to say this is an example of a filament in the bulb. And this says the two sides of the filament are connected to two important spots on the outside of the bulb. Now, we can actually tell what those two important spots are by looking at how this bulb holder is constructed. One red wire is connected to the screw-in part of the bulb, and the other red wire is connected to the very, very bottom of the bulb. If we actually unscrew this bulb and look at it in a little bit more detail, we're not actually going to dissect it, but we're saying that one side, one of these like stick wires is connected to the screw-in part, and the other is connected to this tip of the bulb on the bottom. So we're going to actually show that with our drawing. We're going to say one side of the stick is connected to the screw-in part, and one side is connected to the very bottom, actually inside the bulb. And the bulb will only light up if, let's say we've got the high pressure side of the battery connected to one side of the filament and the low pressure side of the battery connected to the other side of the filament. I'll leave it to you to figure out with your own experiments whether it matters which side of the battery is hooked up to which side of the filament, but the important thing is the bulb will only light up if these two important spots, I'm going to put an asterisk here, because the two important spots are the side of the bulb and the tip of the bulb. A few more things that we want to get out of these notes that are new. Some of these things I think that you picked up maybe from a lab in class, but this we haven't seen before. This says, on a circuit diagram, symbols are used to show various objects. So for example, a battery is not going to be drawn this way. A battery is going to look like this, with two lines, one of them longer than the other. Sometimes you'll see more than two lines. You'll see like a short line, then a long line, then another short line, then another long line. That's basically the same idea. It could mean two batteries next to each other, for example. But it is important that we recognize that this battery still has a low pressure side and a high pressure side. That idea is still useful even when we draw the battery to look like this. A bulb is going to look like this. The simplest possible way to communicate to everybody that we are hooking up a bulb, a circle with two wires sticking out of it, and a wire, as you can imagine, just looks like this. It doesn't necessarily have to be a straight line, but usually when we see bends in a wire, we will do that like this. Or if we see a split in a wire, we will do that like this. We'll try not to draw curved lines in our circuit diagrams if possible. Last thing we're going to take notes on here, this says, how can we annotate bulb brightness on a circuit diagram? This word annotate, I'm not sure if you're familiar with it, but it means to basically take a diagram and draw all over it to say some more useful things. So we're going to see some complex circuit diagrams. We want to know how to annotate how bright the bulbs are. And it's really, really simple. It works like this. A bright bulb is going to be that same symbol, but we're going to show a bunch of lines sticking out of it. Like this one has 8 lines sticking out of it to show that it's super bright. This one over here, we'll say, is a dim bulb. The symbol for the bulb is the same. It's the same bulb, but it has fewer lines. So in general, for this annotation, we need to keep in mind that more lines means a brighter bulb.